Okay guys, we're talking about upper and lower sums. We've already talked about this a little bit, but not to a great extent like we're going to today. So listen up, and we're going to be looking at how to find these upper sums and lower sums. What these do is they're going to estimate the area. See, integration will find the exact area, but before we do integration, we want to have some idea for an estimate of the area. So we want to be bounded by the curve, bounded by the x-axis, and then bounded by whatever numbers were given. All right, so let's look at these. Here's our function. F of x equals x squared plus 2. It's already graphed for you. See how that's our curve? It's just a parabola shifted up 2 units. All right, use pen to draw 4 rectangles to represent the upper sum. Upper always means above the curve. Bounded by the axes, so here's our axes. Here's one axis, here's the other. So we've got our y-axis and our x-axis as boundaries. Then we're also bounded by the function. Here's the function. And then we're also bounded by the line x equals 2. X equals 2 is this line right here. So the area that we're trying to find is this area right in here. And we're going to use upper sums, 4 rectangles. Now, if I'm going between 0 and 2, and I have to fit 4 rectangles in there, what is going to be the width of each rectangle? A half, isn't it? How did you get that, Michael? Right. To find out the width, we just had to do 2 is the distance from 0 to 2, that distance is 2, divided by how many rectangles we need. So 2 divided by 4 is 1/2. That's the width of each of our rectangles. So now I'm going to use pen to draw my 4 rectangles. So I need a width of 1/2, and I need to have an upper sum. See, look guys, here's my width right here, 1/2. Am I going to use the first point or the second point if I have to be above the curve? Second point. So I'm going to use this point. I'm going to draw this rectangle. There's my first rectangle. Now my second rectangle, I still have to have a width of a 1/2. See, here's 1, here's 2, here's 1/2, here's 1.5. Okay, so now am I going to use the first point or the second point if I need to be upper sum, above the curve? Second, so I'm going to use this point. I'm going to be above the curve to find the upper sum. There's my second rectangle. My next rectangle, first point or second point? Second, to be above the curve. And then my fourth rectangle, width of 1/2. First or second point, got to use the second to be above the curve. So here's all the areas that I'm going to be computing to estimate the upper sum. And it's actually not an estimate, it's an exact answer for that upper sum. All right, now the next thing it says is make a chart to find the height. So I'm going to make a chart to find the height when x is 0, 0.5, which is 1/2, 1, 1.5, which is 3/2, and 2. I'm going to find the height. Well, the height is the same as f of x. The height of these functions is the same as the function itself at that value. All right, so what happens if I plug in 0 for x? Plug in 0 for x. What's 0 squared plus 2? 2. Then I have 1/2 squared. Well, 1/2 squared plus 2. That's 1 squared over 2 squared plus 2. So that's going to give me 2 1/4. 2 1/4 is 9/4. Plug in 1. 1 squared plus 2, that's 3. Plug in 3/2. 3/2 squared plus 2. 3 squared is 9. 2 squared is 4. That's 2 1/4 plus 2, that's 4 1/4, so that's 17/4. Plug in 2. 2 squared is 4 plus 2 is 6. There's my chart. Some people have a hard time figuring out those values. If you're one of those people, here's how you can figure out the chart too. Go to your calculator. Go to y equals, and let's put this in. So our function is x squared plus 2. I'm going to look at my table because I'm trying to make a chart. A chart is the same thing as a table. So second y equals, or second graph rather, here's my table. But I'm not seeing 1/2, 1.5. So what can I do to change the way this table is working?
You can just type in a value.
I could, but I can also go to second window, and I can go to table start at 0. What do I want it to increase by every time? 1/2. So I'm going to do 0.5. So now when I go back to my table, see how now it's going to give me all the answers for all those 0.5s? So I've got 2, and then I have, my answer I came up was 9/4, that's the same, 3, 4.25 is the same as 17/4. So see how now I can check my answers there. Or I could even not even do it in my head, I could just get the answers from here. All right, so we've got that. So now we're supposed to compute the area by using the upper sum. So the upper sum then, oops, that upper sum is going to be equal to, these are rectangles. To find the area of a rectangle, it's base times height. What's the base here? How far is that from here to 1/2? So it's going to be 1/2 times the height. Which point am I going to use? Is it the 2 or the 9/4 that's the height there? 9/4 is the height, isn't it? So I have to use 9/4. Plus my next one, base times height. Well, that base is 1/2. What's the height going to be? For this one, what's the height? When x is 1, what's the height? 3. It doesn't look exact. Well, because I didn't draw it perfectly. There we go. Okay, and then my next one, that's 1/2. What's the height for the next one? 17/4. And then plus, and then my last rectangle is 1/2 times what? What's my height there? 6. Okay, so now I have to do all of this. I'm just going to do it without a calculator. It's going to be 9/8 plus, this would be 3/2. 3/2 though would be 8. I'm just going to get a common denominator. 3/2 would be 3 times 4, 12/8. This would be 17/8. And this would be 6/2, which is 3. I'll just keep that as 3. Okay, so now adding these, this would be 29 and 9 is 38/8 plus 3. Well, 38/8 is going to be 19/4 plus 3. That is 4 3/4 plus 3. That's 7 3/4. Okay? Now, I could also type all that in my calculator. But if I were going to type that in my calculator, I wouldn't type it in as 1/2 times 9/4 plus 1/2 times 3 plus 1/2 times this. What can I factor out of each one of these? 1/2. So couldn't we just do 1/2 times parentheses 9/4 plus 3 plus 17/4 plus 6? That would be a lot faster, wouldn't it, to type it in that way? So keep that in mind. In fact, I'm going to check this answer just to be sure. So I go to my home. It's going to be 0.5 parentheses 9/4 plus 3 plus 17/4 plus 6. And it's 7.75. So our upper sum is correct. Questions on how I got the upper sum? All right. So now we're going to use pencil to draw 4 rectangles to represent the lower sum. So what do you think we do with the lower sum here? Instead of going above it, we're going to be going below it. So looking at our first rectangle, I'm going to use my first point because I have to stay below the curve. So here would be my first rectangle. I have to use this point to be below it, this point, and this point. So my lower sum is going to give me an underestimate of that area. What's the width of each rectangle again? What's the width? 1/2. So now we're going to compute that lower sum. Now let's be using some common sense here. Instead of doing 1/2 times the height plus 1/2 times the height plus 1/2, I can just do 1/2 times all of those heights, right? The sum of all those heights. Okay, so what's the height right here at my first one? 2 plus the next one's height. Use your chart. 2 is our first height. What's our next one? 9/4. Next height. And the last height. Now, what people do wrong on the quiz? What do you think they do? What would be a common mistake, you think? They look at this chart, and what do they do when we're doing this lower sum? No, the thing they do is they use this last point. Would you need to use that last point if you're only doing 4 rectangles? No, you only have 1, 2, 3, 4 points to use. Okay? So now we're going to have 1/2 times, what is that, 5 plus 26/4, which is 13/2. So 13/2, 6.5 plus 5 is 11.5. So half of 11.5, just do it like this. Half of 11 is 5.5 plus half of 1/2 is 1/4. No need for calculators, so that's 5 3/4. Or get out a calculator if that was confusing. So that's our lower sum. So here's our upper sum, here's our lower sum. It says make an estimate for the area of the region bounded by the axes f of x and the line x equals 2. And it says using lower sums, but this should be just using both sums. It should say both instead of lower. How would I find a good estimate by using my upper sum and my lower sum? What would I do if I have something that's too much and something that's too low? What would give us a very good estimate? Well, okay, but what's that also called? The average. Median's not truly the average, but we want the average of these two. So what is the average of 5 3/4 and 7 3/4? 6 3/4, right? Isn't that in the middle? Okay, so a very good estimate would be 6 3/4 using our lower sum and our upper sum. Now, the last thing we're supposed to do is use our calculator to graph this. So we're going to go to our calculator. We're going to type this in, x squared plus 2. Do a zoom 6. Here's the function. How do I have the calculator tell us the actual area? Second calc, and then which one? 7. That's going to give us the area. Okay, this one, dy dx, gives us the slope. We want the area. And then our lower limit means our lower x value was 0. Our upper limit is our upper x value, which was 2. And it shows us that that area is 6.6 repeating, which is 6 2/3. So was that a pretty good estimate? Yeah. 0.75 and 0.66, what is that? I mean, that's only off by about 9/100 of a square unit. All right, any questions on that? So just real quick, When you make a chart, that's always helpful, but you don't always use every value in the chart. You're only going to use 4 of them because we're only finding 4 rectangles, so you don't need to use all the heights every time. Okay, any questions on anything? All right. So you have a work